Find the gradient of each of the following. So we have here a function f of xy, a function of two variables, and the gradient vector, the gradient of f, is a vector of partial derivatives. It's f sub x, comma, f sub y. So the derivative with respect to x, y cubed is a constant, so the derivative with respect to x is 0, and the derivative of a constant times x is the constant y. Then the derivative with respect to y, this is a constant times y, so the derivative is the constant, minus the derivative of y cubed is 3y squared. So this is our gradient vector, f sub x, comma, f sub y. In the second case, we have g of xy, so the gradient of g is g sub x, comma, g sub y. This one's going to require a chain rule because the variables are under a square root. So we have to recall the derivative of the square root function is 1 over 2 times the square root of x, and that comes from the square root function is x to the power 1/2, and when you take the derivative, you use the power rule of 1/2 x to the minus 1/2, which can be rewritten using the square root. So g sub x, we take the derivative of the square root, leaving us with 1 over 2 times the square root, leave the inside in, and then times the derivative of the inside with respect to x, so that a y squared will become 0, and x squared, the derivative is 2x. And then g sub y is similar, derivative of square root times 2y. So 1 over 2 times the square root, and then times 2y. And we can simplify this slightly by canceling some 2's and writing the first component as x over the square root of x squared plus y squared, and writing the second component as y over the square root of x squared plus y squared. So there's our gradient vector, f sub x, comma, f sub y. And in part C, we want the gradient of h. Now h is a function of 3 variables, x, y, and z, and so our gradient will have 3 components. It will be h sub x, comma, h sub y, comma, h sub z. The derivative h sub x, the derivative of this function with respect to x, this is just x times a constant. Sine yz is a constant as far as x is concerned, and so the derivative with respect to x of a constant times x is just the constant, so that's sine of yz. And then the derivative with respect to y, so y is inside of the sine function, so the sine function is on the outside, and so we have to take the derivative using the chain rule. The x is a constant, so it will just sit there, and then the derivative of the sine is cosine, leave the inside in, yz, and then times the derivative of the inside, that's a constant times y, so the derivative is the constant. And h sub z is similar to h sub y. We still have the sine function on the outside, but now our variable is z, so y will be treated as a constant, and x is still a constant, so the derivative is going to be x times the derivative of the sine, cosine, leave the inside in, yz, and then times the derivative of the inside, which is a constant times z, so we get the constant. So there's our gradient, and we can just rewrite it slightly, putting the xz together as the coefficient of the cosine in the second component, and xy is the coefficient of the cosine in the third component. So we have sine of yz in the first component of our gradient. We have xz cosine yz as the second component, and we have xy cosine yz as our third component. So this gradient of h is h sub x, comma, h sub y, comma, h sub z. The gradient is a vector, so maybe even in the instructions it could even say find the gradient vector. It's a vector of partial derivatives.